These are my CNC plasma tables. I have the Star Lab sitting here. And this one back over here, I've had this one for about 15 years. This one is a plasma route CNC table. It's called a 4x8 table. It'll actually take a 5x10 sheet of steel, but it won't quite cut all the way to the edges. It'll get close, within a few inches. This one is a 5x10, and I'd had this one served for several years, and so I thought, well, it's just time to buy another one. It sits here mostly unused. Here the other day, the DTHC4 card went out in this one, and I stole it out of this one and got that one back up and working, and we're working on getting the new card for this one, so it'll be in soon. Has a hypertherm 85 over here. The air compressor's back over here, and there is a air dryer sitting down there, and all of the air is plumbed along there and piped. Over in this corner is a hypertherm 105, and so I've had this table for a long time. I bought this table new, and it came with a Thermal Dynamics 83 and had an A60 torch on it, an 80 amp plasma. Used it for several years like that. Later, I purchased a hypertherm 105, and I've had that since September of 2015. This table originally came with Mach 3 as the control software, and it came with one of the early generation of Tom Cottle's controller system, CNC. It's an older version, and it's been upgraded to the newer stuff quite a while back, and I think I was one of the first ones that ran Command CNC. Tom came out and was helping me troubleshoot, and I decided to upgrade. I said, I sure wish I had one that would run on Linux, and he said, well, we've got one coming out. And so I actually paid for it before the release date, and I've had it for a long time. Like it pretty well. And so I'm working on getting both of these tables, just kind of fixing the oddball things that's wrong with them. This table I've never used. Actually, I cut one time with it, and it's had a sheet of steel laying on it for a long time. I just haven't used it because this one has worked pretty well for me. I had a problem with my hypertherm 105, and so about a year ago I was having a problem, and I wasn't getting torch volts displaying over in Command CNC, and as a result, my torch height controller didn't work. We was able to keep cutting without it, but at first I thought it was my PWM. I upgraded my PWM to a PWM 2A, replaced them. Nothing helped. I found out that it was the DTHC4 card in this guy. The controller's actually on the other side of that wall. But I stole the one out of the Star Lab, got it working, diagnosis, and it worked fine for several months. And not very long ago, I quit getting torch volts. Again, I don't know if you can see over there on that screen across there, but no torch volts displayed. And you know what you do is you come to the PWM, and on the back of the PWM there's a couple of test ports, and I don't know if I can, I'm holding my phone, I don't know if I can do this well and show it at the same time. I'm going to have to switch hands, I think. The screen over there, when I take this, I'll take this sharp pointy thing and poke in this hole. There's a button on the inside of there, and it pushes the test button, and it will make 120 volts appear on the screen over there. It's just a test mode. That will, the pulse width modulator will send out a signal through this Cat5 cable. It'll go around, go into the controller on the other side of the wall, goes to the RS485 hub, and well, actually no, it doesn't. It goes into the DTHC4 controller, and then that talks RS485 and USB, I think. But anyway, it gets the voltage to the control software. So a way to test that is to push that button, and I can't do it with one hand, so just take my word for it. When I push that button right there, that 0 over there, I can see it going to 120 volt. That tells me that my PWM's in good shape. That tells me that my Cat5 cable's good, my DTHC, all of that's good. On the so what the torch volts do is they measure potential at the end of your electrode and at the plate at your work lead, and they measure the difference, and that's how it calculates the voltage drop across there, and that correlates to the distance that you're cutting. And so that's what we're feeding back. And over here, get my light over here. Inside here we have my work lead, and there's my torch lead. So there's the big electrical cables coming from the transformer up to the torch lead, and there's also the large cable that goes over to the main board that brings the work lead. And there's a small red wire that comes off of this. It's also bound into that, and it goes to the main board as well. So when I get the negative torch and the positive work potential, I could tap it there, but that is measured over here on this board. So that little red wire comes in right here, and the work lead comes in right here. And on the board, on the circuit board in this hypertherm 105, there is a voltage divider. It reduces the voltage by a 20-to-1 ratio. So for example, if we was talking about 100 volts, then at a 20-to-1 ratio, I would be measuring 5 volts. And that sends that out through this little wire here, this little red and black wire down here. So the torch volts that have been measured on the board are reduced to 20-to-1 ratio, and they're sent out through this little cable that comes up here, goes through the back, and then it comes to this circuit board here, this little voltage divider. And if all of the switches are down, then it just passes that voltage straight through to the wires on the other side. So once they've passed straight through, so they come in here, pass through, and go out here. That goes across to the CPC connector that connects between the MIC cable. The MIC cable then goes to the PWM, and that's how the voltage is delivered. There are different ratios. For example, you can see that there is if we flip up dip switch 1, it's 21-to-1. If we flip up dip switch 2, it's 30-to-1. Dip switch 3 is 40-to-1. And dip switch 4 is 50-to-1. And then you have to set the corresponding dip switches on your PWM to match that. I think the 21.1 is for plasma cam. It's a special thing for plasma cam. And anyway, that works great when it works. On my unit here, this hypertherm 105 is, well, it's 8 years old, so I'm long since out of warranty. And if you remember, I said earlier, my problem is that I'm not getting torch volts. If I measure with a meter at any of these points, if I measure here, I'm not getting the divided voltage from my main board to this board. And it's kind of a common occurrence that the onboard divider will go out. I've seen Tom post that it's a capacitor that goes out. I don't know. I know that you can get them repaired, but they're expensive to repair. And so what happens is Tom, CNC, they make this rav-02 card, and this rav-02 card will install inside of pretty much any compatible plasma unit, and it will give you all of the things you need to make it automated. And one of the things it gives you is torch volts, right? So what I would do is I'm going to, per the instructions, I am going to tap into this bolt and this screw. I'm going to crimp some connectors on, bolt on there. I'm going to run 2 wires, and I'll find a place inside the chassis here to mount this board, and I will connect them here and here to the appropriate places. And then there is a stereo cable that plugs in to the stereo jack, takes that out to the PWM. And in my case, I don't need to use the other control circuits on here because they're already present in my 105. And so that's all I have to do, is I just have to mount this board inside my hypertherm 105, and I have to route wiring from the work lead and the torch lead, and I'll get that voltage to here, and that is raw arc volts. And then this board is going to divide it. It's going to divide it at a 7-to-1 ratio. And then it's going to deliver that divided voltage 7-to-1. I think that's what it is, 7 or 7.5 to 1. And it's going to deliver that to the PWM. I will then go to the back here and change these dip switch settings to be appropriate for the 7-to-1. You see there it says rav-01. It's upside down, but rav-01 7-to-1. And then at that point, I will have repaired my hypertherm 105 so that I will have torch volts again, and my THC should work. I've got to find the place inside here where I want to mount it. You see there's lots of void areas on this side that should be acceptable, so I'll come out with a way to mount that in there, route my wires, and get it going.